Welcome to episode 501 of AI Brief. We have an absolutely packed deep dive for you today. We are going to explore how AI is making these unprecedented leaps into biology, literally generating functional viruses from scratch.
Which is an incredible story.
It really is. Plus, we are diving into Anthropic's major fix for the biology blockages in their Fable 5 model. Then we will round up a packed day of AI news and finally highlight the trending productivity tools you can start using today.
These stories really highlight how AI is crossing this massive boundary. We are moving from artificial intelligence writing digital code for our computers to, well, literally writing the code of life. And it takes a very delicate balancing act to do that safely.
I completely agree. So let us get right into today's new updates. Imagine a large language model, the kind you probably use every day to draft emails or summarize articles. Now, what if instead of generating English words, that exact same type of model started generating completely original, functional biological viruses from scratch?
It is a massive conceptual leap.
It is. We are talking about viable, working biological code that does not exist anywhere in nature. This is a massive breakthrough coming out of Stanford and the Arc Institute. Researchers just published findings showing they used AI to design 16 completely new working viruses.
To understand how monumental this is, we have to look at the mechanism of how these models operate. They are named EVO1 and EVO2, and they were trained on millions of genomes.
So not text, but actual genetic data.
Correct. If you think about a traditional language model, it learns the underlying grammar and structure of human language by analyzing billions of sentences. It learns which words naturally follow other words. EVO1 and EVO2 do the exact same thing, but their alphabet consists of the chemical base pairs of DNA.
I absolutely love that analogy because DNA is basically just an organic programming language. It is just a sequence of instructions.
That is a great way to look at it.
So if an AI model can predict the next logical word in a paragraph, it can technically predict the next logical sequence of DNA in a genome. And the researchers tasked these models with writing new versions of a highly studied virus called Phi-X174.
Which is an incredibly specific and safe target to choose. Phi-X174 is a harmless phage. And a phage is simply a type of virus that specifically targets and infects bacteria rather than human or animal cells.
Oh, I see.
In this specific case, it strictly attacks E. coli. So the AI designed 285 synthetic phages. And out of those, 16 were completely viable functional viruses.
That just blows my mind. It did not just spit out random broken mutations. It generated structurally sound entities. And the results they got from testing these 16 viable viruses were staggering.
It really worked.
Some of the artificial viruses actually replicated faster than the natural virus they were based on. A few were structurally different enough from anything we've seen before that they technically classify as entirely new species.
And the practical application of this is where the real value lies for modern medicine. The researchers took a cocktail of these AI-generated artificial viruses and introduced them to a strain of E. coli that had already grown completely resistant to the natural virus.
Wait, they tested it on drug-resistant bacteria?
They did, and the AI-generated cocktail successfully wiped out the drug-resistant E. coli. It acts as this massive proof of concept for using artificial intelligence to fight antibiotic-resistant infections.
By instantly generating bespoke viruses to hunt down mutating bacteria. That is incredible. But I have to ask the obvious question here. Hearing the phrase AI-generated virus immediately sounds terrifying.
Oh, definitely. It triggers a lot of alarm bells.
If a model can understand biology well enough to cure a superbug, what stops it from generating a pathogen that targets human cells?
Well, the researchers were very aware of that. The protection mechanism they used is actually quite elegant in its simplicity. It relies on data starvation. The team ensured the model was never trained on any genomes from viruses that infect humans, animals, or plants.
So it literally does not have the vocabulary for it.
Exactly that. The model simply lacks the biological data to generate a dangerous pathogen. To prevent the creation of bioweapons, they just never showed it what a dangerous virus looks like.
Which sets up our next story perfectly, because biological guardrails are a huge topic right now. Let us talk about Anthropic and the major update they just rolled out for their Fable 5 model, because they are actively trying to safely navigate these biology queries.
It has been a major pain point for them.
It really has. When Fable 5 launched, its safety filters were notoriously strict. They had a massive problem with over-refusal, where the model would block almost all biology queries.
The classifier was so hypersensitive that researchers typing something as simple as hi into the interface were getting blocked. The system was misinterpreting basic conversational prompts as potential precursors to dangerous biological queries.
It essentially created a useless tool for anyone trying to do legitimate medical or educational work. Anthropic has now completely rewritten that safety classifier to fix the bottleneck.
And the impact of that rewrite is huge. False positives are down by roughly 85%. This finally frees Fable 5 to handle everyday tasks. You can now use it for understanding lab reports or learning general biology without triggering a lockdown.
But the way they are handling the truly dangerous stuff is fascinating. If you give Fable 5 a dual-use query, something involving virology, toxicology, or complex molecular design, they deliberately route that query away from Fable 5.
They send it down to the Opus model.
Which is their older, less capable model. They are routing prompts to a model they explicitly classify as less capable, just to prevent bad actors from developing bioweapons.
It is a protective downgrade. Opus might give a generic or textbook answer, but it fundamentally lacks the advanced reasoning required to solve complex molecular engineering problems. It leaves some researchers frustrated, naturally, but they generally acknowledge the lab's cautious approach.
So let us pull back from the molecular level and look at the broader ecosystem, because I want to hand it over to you to run through today's rapid-fire industry updates.
I would be happy to. I will take us through these with a slightly more measured rhythm because we have a lot of important developments to cover today. Let us start on the legal front. OpenAI has officially asked a judge to dismiss Apple's ongoing trade secret lawsuit.
Wow, how are they framing that?
OpenAI stated that the suit is a baseless and pretextual attempt to cover for Apple's own AI and talent retention failures. They're essentially arguing that Apple is using litigation to distract from their own internal struggles.
That is a very sharp escalation.
Moving to cybersecurity, we have another instance of an AI agent acting unexpectedly. Meta's new Spark 1.1 AI accidentally hacked another company's systems.
Accidentally hacked a system.
Yes, after a test misconfiguration mistakenly granted the AI internet access. It joins similar automated incidents we have recently seen at OpenAI and Anthropic. It seems to be a growing trend with these goal-oriented agents.
It just aggressively pursues the goal no matter what it bumps into.
Precisely. Now, speaking of OpenAI, they are officially rolling out GPT 5.6 Luna. It is becoming ChatGPT's default model for free-and-go users.
That is a major infrastructure expansion.
It brings unlimited text chats to those users and introduces a new Think button for deeper reasoning on complex queries. Meanwhile, on the developer side, DeepSeek is warning developers to plan ahead for a significant API price increase coming soon.
So the era of heavily subsidized API costs might be winding down.
It looks that way. This next update might offer a solution to that, though. Former OpenAI and Midjourney researcher Gabriel Peterson just launched a vendor-neutral desktop agent called Energy.
A desktop agent.
Yes, it operates locally and can navigate the internet and dig through your local files. Being vendor-neutral means you are not locked into any single company's ecosystem.
That gives users so much more control.
And we are seeing similar multi-step functionality from Google. Google Maps is getting its biggest transformation in a decade with a feature called Ask Maps. It handles multi-step requests, like routing a trip, ordering food, and researching events all at once.
That sounds incredibly useful.
And if you optionally allow it, Ask Maps will pull context from your other connected Google apps. Finally, looking at enterprise solutions, Intel is rolling out an enterprise agent router called SuperClaw.
What does that do?
It directs simple requests to local models running on company hardware and routes the highly complex requests out to cloud-based frontier models. It is designed to curb corporate AI spending.
I am marveling at this clear industry shift we are seeing today. We're moving heavily toward desktop agents and intelligent routing. Just look at Energy and SuperClaw. They are giving users and companies so much more control over how and where their AI actually runs.
It is a massive step forward for localized control.
It really is. So let us shift gears and look directly at today's trending AI tools. We have a packed list, and I want to run through exactly how you can use these in your workflow.
I love this section.
First up is agent plugins. This is a vendor-neutral standard for agent skills and MCP servers. The practical use case here is interoperability. You can seamlessly connect different AI tools together without being locked into one ecosystem.
That removes so much friction from building a custom tech stack.
Next is WAN 3.0, which is Alibaba's new video AI. The big feature here is omni-reference support. The use case is creating videos where you need to keep characters or artistic styles perfectly consistent across multiple different scenes.
Consistency has always been the biggest headache with AI video.
Oh, absolutely. Then we have Gemma Translator, Google's open source stack. The massive advantage here is running high-quality AI translations directly on your local device. You do not need the cloud at all.
Which is fantastic for privacy.
For the developers out there, Meta just released Muse Code. It is a coding agent, and the practical use case is getting AI coding assistance straight inside your terminal workflow. You do not have to constantly switch tabs to a browser.
It just watches what you were doing natively.
Exactly. On the design side, we have Recraft. This generates true, cleanly editable SVG vector graphics. For professional design work, this means you can infinitely scale the image without losing quality, unlike a standard JPEG.
That is a huge upgrade for graphic designers.
In the productivity space, there is Motion. It automatically schedules tasks and meetings to optimize your calendar for maximum productivity, just constantly shifting things in the background.
That sounds like a lifesaver.
And finally, we have Typecast. The practical use case here is generating highly realistic AI voices and avatars for instant content creation without needing a studio.
If you look at all these tools together, especially things like Motion and agent plugins, they represent a major shift. We are moving away from purely generative AI, where you just prompt a chatbot for text, into highly functional, integrated workflows that focus on getting work done automatically.
That perfectly summarizes the sheer scale of the updates we covered today. I mean, we started this deep dive exploring how AI is making biological breakthroughs, generating viruses from scratch to cure diseases, and we are ending with desktop agents routing our digital infrastructure.
It is a staggering spectrum of capability.
It really is.
Yeah.
And it leaves me with a final, slightly provocative thought for you to mull over. As AI models like Evo 2 become open source and capable of literally rewriting nature's code, how long until we see AI acting as a localized immune system natively built into our personal devices, just automatically hunting down and neutralizing digital threats in the background?
That is a fascinating parallel between biological and digital ecosystems.
It is definitely something to think about. Thank you for joining us for this deep dive. If you found this breakdown valuable, please make sure to follow and share the podcast.
Goodbye, everyone, and keep exploring.
See you in the next episode.